Here we go with 3.4. We are going to continue on with those free body diagrams. Draw them carefully because when you write out your equations, make sure the x stays in the x and the y stays in the y. Same as what we did before for distances, like the range was in the x and the height was in the y. Those free body drawings are really going to come in helpful for these units. Just a reminder, kinetic means moving and static means stationary or at rest. So here we have a situation where we have the same picture frame, but we want to figure out how we want to attach it to the wall. Which configuration is going to be the best? Now, all of these use 2 wires, so we're only comparing 2 wires with 2 wires with 2 wires. And when we look at that, that means we have 2 forces of tension. They are acting upward because they're going opposite the force of gravity. Remember, the force of gravity is always down to the center of the object with the most mass. So that would be our free body diagram. Number one thing people do wrong here is they say that there's 2 force of tangents minus the force of gravity equals 0. That is not keeping the x with the x and the y with the y. We need to separate those component forces out. So we know it is no acceleration because the picture frame isn't falling to the ground or floating to the ceiling. And with that 15 degrees at the horizontal, that means it's in this little area right here. We need the opposite side to make a triangle. So we're going to need that sine of 15. Okay. So one tension of one string is the force tangent times sine of 15 for the y direction. How many do we have? We have 2. So we will have 2 force of tangents times sine of 15, okay, minus the force of gravity equals 0. How did I know it was 0? Because I have balanced forces. My acceleration was 0. So my sum of my forces is going to be 0. So what does that tell us? That tells us that 2 times the force of tangent sine 15 is going to equal to the force of gravity. That is just the one free body diagram. If we were comparing it, we need to also do the equations for the second and the third one. Okay? When you write down all the equations, if you are good at algebra, you can just compare them with the equation and tell me which one is the worse or which one is the better, depending on which essay that you get. Which situation do you think is better and why? But you have to show the math. So make sure you're showing the math for all 3 versions and using that to justify your answer, not just the logic of, oh, this would be better because blank. You can start with that, but that is not going to give you full credit. You need the math. Now, if you're sitting here looking and going, okay, this does not give me any idea about which is better or worse, then you would solve for the force of tangent. Okay, and you're like, but I can't do that because I don't know the force of gravity. The force of gravity is the mass times the gravity. So I would use 10 here because it can make it easier. So use gravity as 10. And what can you use as the mass? If you're comparing all 3 picture frames, make them all the same mass. Okay. So do one free body diagram at 15, one at 45, one at 60, have your 3 equations, one at 15, one at 45, one at 60, and solve for the force of tangent. That's going to give you some math answers to back that up. Right, let's do another problem. 100 kilograms safe, that's our mass. Slides across the floor. That means we know we're going to have a force of friction and we're going to have a normal force. And the mover added a strap at an angle of 45 degrees. That's our theta. Pulled with a force of 50 newtons. That's our force applied. And here's our mu. So again, reminding us we're going to have a force of friction. Go through and identify each part so that you know what information is going to be valid for your free body diagrams. For here, we're going to be finding the acceleration. You could get a problem like this and it just wants the force of friction or just wants the normal force. Make sure you read carefully to see which part you need to submit for a particular problem. Always start with your free body diagram. I start with the 4 standard forces, but you can do it differently. We have a force of gravity. Okay, we pretty much always do, acting down. We have motion, so we have a kinetic friction. So we're going to have a force of friction that goes opposite the motion. So the arrow's opposite. We have a surface force, so we have a force of normal. And so what is wrong with our force applied? That one's at 0 degrees, but our force applied here is at 45 degrees. So here is our free body diagram. No, the arrows are not adjusted yet. That is okay on these because you're just trying to get the equation properly, and then you can adjust your arrows at the end if it wants you to submit a free body diagram. Separate the forces. So that force applied needs to have its X and Y component. Where this theta is, that means the X direction is closest or adjacent. It's going to be our cosine. And the other part of the triangle is going to be our sine because it is far away. Now, this is how totally legitimate to draw your triangles, but technically there is no body there at the end of this arrow. So in real life, we would actually shift that arrow over to the actual acting point over here. So when you look at it in the textbook, you're going to see it more like this with the resultant force in between the X and Y. And that is typically how it's done in physics class. But while you're getting used to using your SOHCAHTOA, totally you can leave it in the triangular form so that you don't mess up your sines and cosines. So now we have our force applied in both directions, so we do not need to use that now for our free body diagram. Time to set up our equations. So what do we know? What do we know? We're going to do the Y first. Why? Because it's not having any acceleration in the Y, which means the sum of the forces in the Y is 0. We have 2 upward forces, the force applied and the force of normal. So those get positives. We have 1 downward force, the force of gravity, so that gets the minus sign. Force of normal plus force applied in the Y minus the force of gravity is 0. Do we know the force of normal? We do not. The force applied in the Y is force applied sine theta. Force applied is 50 sine 45. So 50 sine 45 minus the force of gravity. The force of gravity is mass times gravity. Mass is 100, and they told us to use the gravitational acceleration as 10. So that would be 1,000 equals 0. So going through that, I can then solve and get myself a force of normal. That would be sine 45 times 50. And I am going to be subtracting that from 1,000. 964.64 newtons. That's my normal force. So that's basically all we're going to get out of the Y direction. What about the X direction? We have the force applied is going to get its positive. It's going to the right. And the force of friction is going to the left. So it gets a negative. This one does not equal 0 because we're trying to find the acceleration of the safe as it goes across. So our acceleration is to the right. We're trying to figure that out. Force applied cosine theta, 50 times cosine 45 minus the force of friction. We don't know the force of friction, but I know I'm going to need to have an answer for that so that I can find my acceleration. What other equations do I have? I have force of friction is equal to mu force of normal. I have a normal force, I have a mu. 0.32 times 964.64. And that is going to give me a force of friction of 308.69. So you can go ahead and finish solving that for acceleration. When you get done, remember we're just putting a magnitude in. So if your acceleration comes up negative, you would still be putting it in as positive for your answer. There's those equations written out just a little bit clearer. And there's the answer if you want to check that out on your own. Right, a 65 kilogram slalom skier. So 65 is what? That's my mass. Goes down a black diamond with a slope of 25. So that is not going to be a force applied. That's going to actually be putting my whole thing at an angle. I see I have a force of friction that I'm going to have to deal with here because this is my coefficient of friction. So I'll be using that to find my force of friction. Again, what is the acceleration? Free body diagrams are your friend. Notice my theta is not on my box this time. So there's a little bit of geometry involved to find your sine and cosine. Your force of gravity straight down because it's to the object of the most mass. It is not equal and opposite to the force of normal here. So go slowly on that. The force of normal is always what? Perpendicular to the surface. So those two forces are not going to come in the same way we have on a box sitting on the ground. What else do we have? We're going to have a force of friction going up. Why is that? Because the motion is going to be going down. The skier is going down. I don't have a force applied. Why not? That skier is not on something that has an engine pushing him down. He's using gravity to go down. So no force applied. Okay. So there is my basic free body diagram. What's the first thing to do? Separate your forces. So this one looks weird, but the force of gravity that's parallel to the surface is going to be a sine. And the force of gravity that is opposite the force of normal is the cosine. So just write that down, especially, I'm not going to go through the geometry proof, but if you're not comfortable with the geometry, just make sure you have that written down. When you're on a slope, the sine and cosines are going to be different than a force applied. Okay. So now we don't need the straight force of gravity anymore. This direction here, I call that my y direction because that's where my force of normal is. So I pretend that's my y direction. I've changed my frame of reference. And this direction with the force of friction, I'm calling the x direction because it's the one going along the ground. Again, that's so I can change my frame of reference so it's not going to mess up my information when I set up my equations. So what do I have? Let's start with the y direction. Why? Because there is no acceleration. So I know that the force of gravity times cosine theta is going to be equal and opposite the force of normal. That's going to be super helpful. For my second part, what's my x direction? I'm going to have the force of gravity sine theta minus the force of friction because it's going opposite the motion, and that's equal to mass times acceleration. Okay. What do I know? Force of gravity is mass times gravity. I have my angle. I don't have my force of friction. How can I find that? Same as before. I have my force of normal from this first problem, and then you're going to find the normal force, and then you're going to use that to find the friction force. And now I have all the components of this and can solve for the acceleration. And if you're doing that on your own to check it out, that would be the acceleration that I got. How about this guy? A slalom skier goes down a black diamond with a slope of 30 degrees and a coefficient of friction, or a mu, that's Greek letter, 0.05. Again, what is the acceleration? Free body diagram is identical to the one from before. So you're going to see a lot of ones. It doesn't matter if it's a skier going down a black diamond or a mover taking something down a ramp. It will all have the same basic free body diagram. Force of gravity straight down, force of normal perpendicular to the surface. Okay, and then some of them will have a force applied, whether or not there was an engine or physically applying a force. If you're pushing a object down the ramp as a mover, you would have a force applied. Skier does not. He just has the force of friction, opposite the motion. Separate out into my component forces. So I'm not going to use this resultant force of gravity anymore. And do not need that because that is from the last problem when we had a mass. This one does not have a mass. So that might scare you at first, but it's going to all work out when you see this. We have that force of gravity cosine theta is opposite the force of normal. So that tells us that the force of normal is Fg cosine theta, same as before. And how about in the y direction? It's still the same thing. Force of gravity sine theta minus the force of friction equals mass times acceleration. We have an acceleration there because we're accelerating as we go down. If they told you it's a constant velocity, then your acceleration is 0. So just always read carefully. Now, this time I'm doing it a little bit differently. I'm keeping things in variables. So instead of substituting in numbers for the force of friction, I'm leaving it mu force of normal. And then I know what my normal force is. So that's Fg cosine theta. So I'm going to substitute that in as well. Why am I doing all this? Because I did not get a mass. And to show you there is sometimes an easier way to solve the problem. Fg sine theta minus mu Fg cosine theta equals ma. Look at this. I have a mass in the first component. I have a mass in the second component, so I can factor out that mass. G sine theta minus mu G cosine theta equals mass times acceleration. That means what? Yep, I can just get rid of those masses. Just get rid of those masses. And so I'm left with this. This is a much simplified formula. This is only working when we have no force applied and we have our theta creating the ramp as opposed to a force of normal. So that will work, yes, in every situation where the free body looks like this. If you have a force applied, do not use the same one in there. All right, so that's just a nice little trick that you can use there and help you out. And it reminds you that, yep, you don't need to have a mass at all for it. Now, sometimes it's going to say use 9.8 for acceleration, and sometimes it's going to say use 10. So read the quizzes carefully. I think this quiz, everything, the acceleration you use is 10, since they have all those sines and cosines in there to throw you around. In college, they're going to make you use 9.80 or 9.81, or there's a couple different ones that are going to happen when you take this in college or for AP or DE credit. And there we go.